Hello everyone, welcome back to the course Materials in Sports. In this lesson we will talk about tennis, as this sport is a great case study to understand the role of materials in sport performance. So let's start with this table showing the top 5 fastest serves ever recorded in professional sports for women and men. At the very top, as of now, is the incredible speed of 253 kilometers per hour. The high-speed first serve has become a major factor in modern tennis, shaping both match dynamics and player strategies. Today, players regularly serve at over 230 kilometers per hour, and that first serve can decide a point before the rally even starts. A powerful serve isn't just an offensive weapon. It is a psychological one too, putting pressure on the opponent and letting the server control the game. So here's a simple question. How does a tennis ball reach speeds of over 250 kilometers per hour? Sure, athletic skills and biomechanics matter a lot, but there's another player in the game: materials. The materials in rackets, strings, and even balls are all designed to maximize power and minimize energy loss. As the tennis gets faster, the combination of cutting-edge equipment and top-level athleticism is becoming more important than ever for success on the court. The outstanding performance of modern tennis rackets is not the result of a single innovation, but rather the interplay between two key components, the frame and the strings. Each plays a distinct role in determining how energy is transferred from the player to the ball, influencing power, control, and spin. In the supporting material of this lecture, you find a great paper published in 2019 that reviews over 100 years of tennis rackets evolution. It looks at more than 500 different rackets models. An interdisciplinary team in the UK wrote the article, and the title pretty much says it all. Materials have driven the historical development of the tennis racket. This chart, which comes directly from that article, shows the evolution of tennis racket materials from 1860 to 2020. For over a century, wood rackets were king, making up more than 90% of the market until the 70s. That's when everything changed. Starting in the 70s, we saw a dramatic shift. Manufacturers began experimenting with new materials. First, they introduced aluminum and steel, often combining them with wood. The introduction of metal frames was a game changer. Unlike wood, metals allowed manufacturers to create the first hollow rackets frame. This meant they could significantly reduce weight while still making the racket stiffer. This hollow design also improved mass distribution and aerodynamics, leading to more maneuverable and powerful rackets and larger heads. But soon after, composites like carbon fiber took over. By the 90s, they had completely replaced traditional wood and metal. By the year 2000, almost every single racket was a composite. The composite materials kept the benefits of a hollow frame, but added a new level of control. Designers could now fine-tune the racket's stiffness by adjusting how they layered the carbon fibers. These allow them to perfectly optimize power, control, and vibration damping for every type of player. This plot shows how racket geometry has evolved by breaking down the racket into 3 parts: the grip, the throat, and the head. It also tracks the racket's center of mass. While the overall length of rackets has stayed pretty constant at about 685 millimeters, the internal proportions have changed quite a bit. First, you can see the throat region expanded over time, especially after the 80s. This change was made to improve the racket's stiffness and control. Second, the head, the dark green area on the chart, got longer. A longer head size means a larger sweet spot and better energy return for the player. Finally, the center of mass, shown by the blue dots, and remain relatively stable. This shows that designers were carefully optimizing the racket's balance and playability, even as they changed materials and mass distribution. Now, let's look at the racket's weight. Till the 80s, rackets were quite heavy. The weight was pretty stable, generally between 350 and 400 grams, and some even went over 450 grams. Then, starting in the early 80s, you can see a sharp drop in the average weight. Modern rackets have stabilized closer to 300 to 350 grams. The graph also points out a few key moments. The Technort and Stratos rackets from Pirelli around the 80s marked the beginning of this weight reduction trend, right when the composites were introduced. Later, rackets like the VS Nanotube from Babolat and the Instinct Power from Head show the rise of super lightweight, high-performance rackets in the 90s and 2000s. This graph shows how the head area of tennis rackets has evolved, and now that change ties closely to material innovations. In the wood era, before around 1970, the head size were small, between about 0.035 0.045 square meters. Some experimental models, like the Dayton rackets in the 30s, used a mix of wood and steels to slightly increase the head size. The transitional periods between the 70s and the 80s was all about experimenting with material, steel, aluminum, composite hybrids started to appear. The classic Prince racket from the mid-70s was a game changer, showing a clear jump in head size. These coincide with the start of the Open era, when demands for performance started rising sharply. With the composite dominance from the 90s onward, racket heads became larger, lighter, and stiffer. Head sizes jumped over 0.07 square meters, giving players bigger sweet spots. So, what's the sweet spot? It's the area on the strings that feels just right. It sends the ball flying with maximum power, minimal vibration, and smoother contact. When you hit the ball in the sweet spot, the racket hardly twists, vibration is minimized so that it feels clean. Energy transfer is most efficient, giving more power and better control. Material innovation hasn't just changed racket frames, it has transformed strings too, which have improved dramatically over the years. As Andrea Agassi puts in its autobiography Open, the advent of a new elastic copolyester string, which creates vicious topspin, has turned average players into greats and greats into legends. This quote really captures just how much strings technology has reshaped modern tennis. Strings can be made of nylon, polyester, or advanced composites such as Kevlar. Copoly strings are mainly made of polyester with a bunch of additives to reduce the disadvantages of poly strings, which tends to lose their tension easily. Agassi talked about how modern strings allow for more topspin. So, what exactly is topspin? Topspin is the forward rotation of the tennis ball as it moves through the air. In simple terms, the ball spins in the same direction as it's moving, like a wheel rolling forward. This spin does a few important things. It generates a downward aerodynamic force called Magnus effect, which makes the ball dip faster into the court. It gives more control, letting player hit the ball higher over the net while still keeping it inside the line. Studies have shown that adding 100 rotations per minute to the ball will reduce the distance traveled by the ball by 15-30 centimeters. And this makes all the difference between in and out of the court. As we wrap up this lecture, let's recap. Racket power is real. Materials have transformed tennis in dramatic ways, especially with the rise of composites. But as Venus Williams reminds us, there is more to the game than technology. She once said, "Tennis is mostly mental. You win or lose before even go out there." And with this thought, I'll see you in the next lecture.